Okay, objective 3 for unit 3, writing equations for a polynomial function. If r is a root or a zero of a polynomial function, p of x, then x minus r is a factor of that polynomial. For example, let's see, if 2 is a root, then x minus 2 is a factor. If negative 5 is a root, then x minus a negative 5, or in other words, x plus 5, is a factor in the polynomial. If one-fourth is a root, then, okay, we can say that it's x minus 1/4, but really we try to avoid the fraction thing except, well, whenever possible. So what we really do is we're doing x equals 1/4, and let's get it so that there's 0 on the other side. So I can multiply by 4 and subtract the 1. And so 4x minus 1 contains that root of 1/4. So 4x minus 1 is a factor. If it's a double root or if it's multiplicity is 2, then just realize that it's to the second power or things like that. So let's do some other examples that are more complicated than just this. Write the equation of the polynomial function f of x containing the points 0, 0, 3, 0, negative 3, 0, and 4, 0. F must be quartic and positive between negative 3 and 0. Okay, so some things to notice. Now, equations. We are writing equations. And so since it's an equation, you need y equals f of x equals whatever is appropriate. In this case, f of x equals. The points that they gave us, notice that the y coordinates are 0 for all of those. So all of these are x-intercepts, or zeros, or roots of the function. Quartic is kind of a fancy word indicating 4th degree. If it was quadratic, it's a 2nd degree polynomial. If it's cubic, it's a 3rd degree polynomial. If it's quintic, What does quintic sound like? Fifth degree polynomial, so on. Okay, the fact that it's positive between -3 and 0. Now, a sketch could be helpful for us here. I think it didn't say anything about a sketch, but sketches can be helpful at times. This was one of those where I think it is helpful, at least a little bit. So if we plot all those points, 0, 0, 3, 0, -3, 0, and 4, 0. Now, it said that f is positive between -3 and 0. Now, f is y, so the y's are positive between -3 and 0. So it's positive between -3 and 0, so it's above the x-axis between -3 and 0. The multiplicity for each one of these zeros is 1, so they all go through. Since they all have to go through, as opposed to bouncing, and it's positive between -3 and 0, we must have to start low and go through, and then go through, and then go through, and go through, and end low. Okay, now that's indicating a fourth degree, which that matches that we have 4 roots, each with multiplicity of 1. Fourth degree. So here we go. F of x equals, start with that. Okay, so 3, 0. Of course, that would be x minus 3. -3, 0. That would be x minus a -3, so x plus 3. 4, 0. That would be x minus 4. Okay, and 0, 0, that would be x minus 0, but what is x minus 0? It's x. Okay, now, if we were to multiply this out, that would be positive x to the fourth, which would be high to high. We don't want high to high. We want low to low. Therefore, we need a negative there. Now, given the information that we are given, this is as much as we could do. We know that the coefficient out here in front has to be negative. It could be -2, it could be -3, it could be -1/2, but this equation would satisfy it. Let's try the next one. Number 2. Okay, so sometimes we just give you the information by writing it out, and sometimes we give you information with a graph. So I'm giving you information with a graph this time. It's not necessarily to scale, but things are labeled. Okay, so ready, set, here we go. F of x equals. Well, I've got a root of -4, and it's bouncing. So what does that tell me about that root? Well, it has to be even multiplicity. So x minus a -4, x plus 4, it has to bounce, so it needs to be a second power, fourth power. Don't go crazy on us. Just go with the second power, unless we have information that tells us to go higher. So x plus 4 to the second, that takes care of that one right there. It goes through at 2, so x minus 2 is a root, and it needs to be an odd multiplicity, so first power, third power, so on. Typically, just go with the lowest power that does work with these problems, unless you have information that tells you otherwise. Okay, so now when we are writing these equations, if they give you another point that's on the curve besides an x-intercept, they've given us enough information to actually solve for the coefficient and to write the actual equation. Unlike the last one, we couldn't solve for the exact equation. We just know that this is a possible equation. This one, we have the y-intercept. Now, so there's always a coefficient out in front. So let's just call it A. We need to solve for A. Now, we did some of this back in the first unit. So if I know this much, and if I have another point that is on the curve, that point has to work in the equation. Now, remember that this point is actually 0, 16. So wherever I see x's, I'll put 0. Wherever I see y's, I'll put 16. So I've got 16 equals a times 0 plus 4 squared times 0 minus 2. Now, obviously, 0 plus 4 squared is 16. And 0 minus 2 is negative 2. And so we can solve for A by dividing both sides by that. And we can see that we get A is 16 over negative 2 times 16, which reduces to negative 1/2. And so that is the actual coefficient A. We were able to solve for it. Anytime they give you an extra point that's not an x-intercept, not a root or a 0, then you can actually solve for the actual coefficient. And this is something you guys need to be able to do. So replace the A with the negative 1/2. F of x equals negative 1/2 times x plus 4 quantity squared times x minus 2. Okay, let's try another one here. Number 3. Write an equation for a cubic polynomial, cubic, degree 3, g of x that only has x-intercepts 2, 0, and negative 7, 0. G of x also has the point 5, 108. Another way to say that would be G of 5 is equal to 108. Those two things are saying the exact same thing. Okay, well, it's a cubic polynomial, which means we have to have 3 roots once we include the multiplicity, and yet we only have 2 x-intercepts. So that means one of those needs to have a multiplicity of 2. Well, we don't really know which one. I mean, it didn't specify. They gave us a point, another point, but we really have 2 possibilities here. So we've got the possibility where we have g of x equals, okay, we got roots of 2 and negative 7. So x minus 2, x plus 7. One of those has to have multiplicity 2. So I'm doing part A, part B. So I'll just say x minus 2 is squared on the first one. And there is a coefficient out in front. Just put an A there. We're going to solve for it. And then we're going to do the other possibility on the other one. So g of x equals a times x minus 2 to the first times x plus 7 to the second. And we'll just work out both possibilities. Okay, so now we're going to use the extra information, that extra point, to be able to solve for A. We'll do it each one separately. So 108 equals A times, okay, now x is 5, so 5 minus 2 squared times 5 plus 7. So that's 108 equals A times, okay, that's 3 squared is 9, and obviously that's 12. So A is 108 over 9 times 12, and that reduces to, well, 9 times 12 is 108. So now, sometimes we work it out and A is positive 1. Now, when A is positive 1, do we actually have to write the positive 1? You don't have to write the positive 1. So g of x equals x minus 2 quantity squared times x plus 7. So that's one possibility, but we have the other one over here. We're going to work that one out as well, because it could work either way. So again, we're going to solve for the A value. So I've got 108 in for the y and 5 in for the x's. 5 minus 2, 5 plus 7 to the second. So that's 108 equals A times 3 times 12 squared. Okay, so A is 108 over 3 times 144. So we reduce it. And so if we reduce that, that's, well, let's see, 3 goes into 108, let's see, 36 times. And 36 over 144, we can keep on reducing. Let's see, 36, if I double it, is 72, and if I double that again, is 144. So this is 1/4. You'll have a little calculator to help you reduce. So we're going to replace the A with the 1/4, and that will be our equation. So g of x equals 1/4 times x minus 2 times x plus 7 quantity squared. Now, again, both of these are correct, because without more information, each one is correct given the situation. We're going to do one more problem, and here it is. Sketch a graph and write the equation for a polynomial function of 7th degree whose graph passes through -3, 0. Okay, well, that's an x-intercept. Passing through, that means the multiplicity is odd and is tangent to the x-axis. Okay, tangent to the x-axis. What does that mean? Well, think back to tangent lines to a circle back in geometry. So tangent lines would touch the circle just at one point, just barely touch the circle. So if the curve is tangent to the x-axis, it's just touching the x-axis at one point. So touching the x-axis, that's bouncing off the x-axis. So bouncing off the x-axis, those are these are going to be even multiplicity. So negative 5, 0. You've got even multiplicity there. The origin, you've got even multiplicity there, and even multiplicity at 2, 0. So if you have even multiplicities, let's just go with the lowest even multiple. So this would be 2, 2, 2, and then one more for going through. That's a total of 7 roots, and that makes up the 7th degree. So those are all the x-intercepts. Everything's accounted for. We could go ahead and we could start to write the equation. Now, sometimes doing a sketch first is a good idea. I don't know that we necessarily need to do the sketch first on this one. Let's write down what we do know. There was this extra bit of information, p of negative 1 equals negative 432. So our function's name is p. So p of x is, coefficient's going to be a. Because of that extra information, we're going to be able to solve for the a. Okay, we have x equals 0. We got the origin with even multiplicity. Remember, it's tangent to the x-axis, so that would be x squared and negative 5, so x plus 5 quantity squared. And the 2, 0 is also even multiplicity, x minus 2 squared. So there's all my even multiplicities. They're bouncing at the x-axis at 0, negative 5, and 2. And then it goes through at negative 3. So x minus a negative 3, x plus 3. So there's our basic function. Remember that p of negative 1 equals negative 432. That's the same thing as saying the point negative 1 comma negative 432 is a point on the graph. So we can plug that in. Negative 432 equals a times, okay, everywhere I see x's, I'm putting negative 1. Negative 1 squared. Negative 1 plus 5 squared. Negative 1 minus 2 squared. And negative 1 plus 3. Negative 1 squared is obviously 1. 4 squared. Negative 3 squared. 2. Okay, so solving for a, let's see, 16 times 9 is 144, and times 2, that's 288. So A is going to be negative 432 over 288. And so if we reduce, like I say, a little calculator is very helpful here. So 4 goes into 432, 108 times. 4 goes into 288, 72 times. They're both still even. 4 goes into 108, 27 times. And 4 goes into 72, 18 times. And okay, now we can see 9 goes into the top 3 times, and 9 goes into the bottom twice. Okay, so A is negative 3/2 And so we have our equation, P of x is equal to negative 3/2 times x squared times x plus 5 quantity squared times x minus 2 quantity squared times x plus 3 to the first. Now, it did say sketch it, so we should be able to sketch this. Okay, so we've got 7th degree, leading coefficient's negative, so it should be coming from up high and going to down low on the right-hand side. It's bouncing at -5, it's bouncing at 0, it's bouncing at 2, it goes through at -3. So starts high, bounces, goes through, bounces, bounces, and finishes low. Okay, so that's -5, that's -3, that's 0, that is 2, and at -1, we're saying it's at -432. So we could just double check that. And so if we input a -1 and into all the x's and multiply by -3/2, we should get -432.